rather. Hi. Very nice to see all of you here. Let's do some last moment preparation. We have 50 minutes. My name is Oleg Šelajev, and we're going to talk about GraalVM. Hopefully this whole thing works beautifully. Right. I'm with Oracle Labs, Oracle, and I work for the GraalVM team as a developer advocate. You can find me online almost universally by @Šelajev. So if you have any questions that you won't get the chance to ask here, you can ask online, right? I feel comfortable saying that I'm old and wise, and I feel like I can give advice on software engineering and programming and life in general. Right. Before, does this work? This doesn't work. Excellent. Right. Excellent. Before we start, please do not make any foregoing business decisions based on the contents of this presentation. This is very important. And with this information out of our way, we're gonna talk further. Let's talk about GraalVM. GraalVM is as you know, of course, the high-performance polyglot embeddable virtual machine capable of running programs in different languages. Thank you. And currently, the set of supported languages is Java and the JVM languages, everything that goes through Java bytecode. We support JavaScript, including the node.js applications. We support Ruby, R, Python, and we support everything that goes through LLVM. So it's a truly polyglot virtual machine, and we try to cover the most popular languages, specifically the dynamic languages that otherwise are very hard to run in the context of the JVM. If you want one picture, one mental image what GraalVM is, I recommend you this slide. Right? If you remember this slide and nothing else from the session, I would feel accomplished. If you remember this slide and my Twitter handle, I will be ecstatic. So all the languages that we support are on top. You can run them inside a single process, right? You can write systems where different components will be created in different languages. You can have your Java application or your Scala application, and you can have a machine learning module there that would be written in Python. If you have people writing Ruby, or if you have an existing Ruby app, or if you have JavaScript developers somewhere in the team, they can write their components in the language where they are the most productive. They don't need to compromise. And GraalVM is able to run all of those languages inside a single process without actually any overhead for crossing the language barrier. In fact, there is a very interesting technology, and we can compile the application across the language barrier. So we can inline your Python code into your JavaScript code if you want. And all that goodness, all those languages, this versatility, we can run that in different contexts. So you can run it on the JVM, and that would be the proper JVM, the actual JVM, and it will do everything the JVM does, except it will be capable of running other languages. You can run it within the context of a node application, and that would be the proper node application with event loop and with the normal signal handlers that Node has, and like the proper node. Let's do a quick question right here. How many of you write Java like daily? I mean like twice a week at least, right? Excellent. Other languages, Scala people, right? On one hand, very interesting. For Scala, we have great results, so please pay attention. This session will be very interesting for you. Node.js applications, right? We have interesting, but maybe not the most fleshed out use cases, so I'd be interested in talking to you. And you'd be interested in checking out. Right, so we can run Java, we can run Node, but also we can, the GraalVM as a runtime was created from scratch by design to be embeddable. You can put it into your applications, whether Java applications or whether native applications, and enable them to process code in those languages. So if you have a large platform and you want to enhance it with the ability to evaluate some JavaScript here or there, GraalVM could be a good choice for a runtime like that. This way, we built GraalVM into certain experimental builds of Oracle database, which is a very large native application which is a database, and you can write user-defined functions and stored procedures using, for example, JavaScript. So normally you would write them using PL/SQL, but if you do not feel comfortable writing complex PL/SQL, you can maybe consider writing JavaScript. And there is also a mode where you can compile your applications ahead of time into native binary, and that would be a platform-dependent native binary without the dependency on the JVM, and it will be small in size. It will be larger than a couple of class files, but it will be small in size compared to the normal deployment unit that you do for your Java applications. And it will start up really, really fast, comparably fast with native applications and Go applications and so on. So that could be very interesting if you would like to use that in environments where startup is important. So this is what GraalVM can do. It's a very versatile platform. The project started something like 8 years ago with the idea that maybe we could write a compiler, and just-in-time compiler, for Java in Java. And, well, we succeeded. When I say we, it's the Oracle Labs team, which I joined just last year, so there is very little of my contribution there. But the project succeeded, and then last year we started converting this goodness towards the industry. And just this month early in May, we announced that we have a release that we feel is production ready, and everyone should look at that and evaluate that. Right. So for the rest of the session, we're going to try to concentrate on certain use cases why you might be interested in evaluating or using GraalVM, and I'm going to try to show a number of demos that will help you understand certain use cases there and certain capabilities. So in general, why GraalVM could be interesting, and this mostly targets the normal Java developers or Java teams, which write like projects written for the JVM. It can be a faster runtime. We are a high-performance virtual machine, so if you run your workloads and you feel that performance is important, then you might consider trying GraalVM. Then this instant startup thing where you can start your application really, really fast. So if you run serverless platforms, or if you use serverless, or if you use microservices and you want to auto-scale your things without the need to start up and warm up JVMs, it could be very interesting. And also, it's a Polyglot VM, enhancing your large applications could be nice, and the interoperability between different languages. Right? Those are currently the main values that I personally see in GraalVM, and we know a number of companies are evaluating, and for each of those, I know at least 1-2 teams who are actually using it, and I sincerely hope that they will publicly come out and say and blog about that, and then my life would be much easier because I would be able to name them publicly as well. So, but let's go with that. If you download GraalVM, if you get the binary from somewhere, you will see a picture like this. You will see normal commands that you get with any JDK. You will get your normal Java commands. There is Java lurking in the corner. There is Java C, so you can compile your Java sources to the bytecode. There is all the other Java commands that you would like to use. But also there are other things. You can see there is a node executable. There is npm. There is a thing called GraalPython that will start our Python implementation. There is a thing to install R, and all of those are in the same folder, right? It's a Polyglot VM that can run all those things normally. And the best is that you can start from any of those, and then, well, have the capability of running other languages as well. So in the default distribution, in the zip archive that you get, you get Java bits and Node and LLVM interpreter. And others you can install using the GraalVM updater utility. So it will just download the jar file and it put it in the correct place. And one of the main ideas was to reduce the initial download size. But you can get the fully functional environment with everything in there in just a number of download commands. How it works when you start it. Say you are starting a Java application. You type a GraalVM/bin/Java. What happens on the inside? So it starts the normal JVM, and our builds feature Java Hotspot, the OpenJDK-based builds. And it's a normal JVM, and it will do everything that JVM does. It will initialize all internal data structures, and it will map the find the class files, and will load the class files, verify them, everything that JVM does normally. But what we swap and how we enhance this application, this Java utility, is we provide a GraalVM compiler as the top tier just-in-time compiler. So when the JVM process will start executing program, and at some point of time it will find that some code is executing really, really many times, and it would like to optimize it further, it will give it to the compiler and say, oh, here's the bytecode, please give me efficient machine code for that. So how do you integrate a just-in-time compiler into your JVM? You implement JVM CI, of course. JVM CI stands for Java Virtual Machine Compiler Interface, and that was the thing added to Java 9. I think it was JEP 243. So it was added to OpenJDK, and we backported it to Java 8, so you can use this with our builds for the Java 8-based applications. And through those two layers, because it's a normal JVM, we can run Java workloads as normally as they would do. Except that when the code gets hot and you need to compile it, the just-in-time compiler will be ours, the GraalVM compiler, and that could produce a more efficient machine code than otherwise. For the other languages, that would be a problem, right? We know that there are implementations of other languages on the JVM or on the in the .NET world, where you take the language and then you compile that to the low-level representation. On the JVM, that would be the JVM bytecode. So you can take Python, for example, and look at the Python program and output the Java bytecode that corresponds to that. You need to build a compiler that will just turn Python into bytecode. And after that, you can say that, okay, this is my Java program, so I will run it normally with those two layers. But it's very hard because it requires you to maintain this compiler, and it requires you to express those high-level dynamic features of those dynamic languages in the low-level vocabulary of the JVM bytecode, right? So it's not trivial, especially when your language evolves, right? If you want to create a JavaScript implementation that is capable of running on the JVM, you would need to keep up with the language standards, which is, in case of JavaScript, is absolutely non-trivial. So we didn't do that. We wanted to support all the languages, and we took a different approach. So we created a framework for implementing managed languages. We called it Truffle Framework. What it gives you the API for creating interpreters for the languages. Right? It gives you a set of Java annotations and a set of Java classes that you can use to describe an interpreter for your language. So you don't need to provide the actual implementation of the compiler, but you just need to fix the semantics of your, say, JavaScript operations using high-level abstract language as Java, because the whole thing is written in Java, which is much, much easier, because when your language changes and there are new versions and you need to add new functionality, what you have to do, you don't have to figure out how to compile it to something else, but you just describe it using high-level language. Normally, this approach would be fairly slow. Interpreters are slow because they need to dynamically evaluate every single small instruction. Say you want to evaluate the expression a plus b, right? You need to figure out what a is, you need to figure out what b is, you need to figure out what plus is, because in several languages you can overload operators and then plus could mean anything. So you need to figure out all those details. That would be several virtual calls for every method invocation. That would be slow, right? No one wants slow software. And especially if you try to create a high-performance virtual machine, you definitely don't want to have a slow implementation of the interpreter there. So Truffle Framework gives you API and gives you some runtime bits for compiling those interpreters on the interpreter level into the efficient implementation. We're going to see one slide about that later. And then it passes to the lower level, to the just-in-time compiler in the JVM. So there are like two types of very high-level optimizations happening. And through that, we can have efficient optimizations of dynamic languages. With that, we have the implementations, as I said, Ruby, R, JavaScript, Python, and also the LLVM bitcode interpreter, which might be like a weird and a little bit strange choice. Like, why would you need to compile, to run the compiled language on the JVM? That kind of or in any virtual machine. Sounds like a little bit of nonsense. But the dynamic languages here, they often come with native extensions. So when performance of a Python module is not what you want it to be, you rewrite certain critical paths in C or C++, because that's faster at the execution time. So since we want to run all of that in the same process, we want to control the whole execution. We want to compile between the Python parts of your Python module and the native parts of your Python module. We need to run it within the same process. So we have the interpreter for LLVM bitcode, and through that we can run C and C++, and through that we can run, say, native extensions to Python or Ruby as they are run in their normal ecosystems. This is very important because this gives us the ability to support the ecosystem without actually requiring a rewrite. Nobody wants to have a different implementation of their favorite Ruby gem, right, or Python module. You don't want a special one. You want to take the software as it is inside the ecosystem, how people run it, and you just want to be the runtime to produce better results. So this is how we do it, right? And then how do you get this goodness? You go on GitHub. It's an open source project. It's available freely. There are, well, open source licenses, which you need to read and understand and agree with, but the code is open. It's all written in Java, so you can look through that. As Java developers, I feel this is a very good thing because you can load that into your favorite IDE. You can click on the class definitions. You can go look around. You can feel like you understand what is happening in the code. It still takes a little bit of learning curve to understand what the compiler is doing because, well, it's a compiler. It's kind of the closest thing to the rocket science besides the actual rocket science. But it's much more understandable than native code. You can build it yourself, and you get the functional binary, and you can use it yourself. If you don't want to build it yourself, then you can download the binaries that the team provides you, right? The GraalVM team gives you two types of the flavors of the binaries. The community edition is the open source version available from GitHub. You can build it yourself, or you can get our binaries based on Java 8. So if you run Java 8, how many of you run Java 8? Right, 8 plus, I mean, like, okay, how many of you run Java 9 plus? What do other people run? How many of you are asleep and don't want to raise your hand? Nice, 2 people. I will remember you. I don't see your face, luckily, but thank you very much. So our builds are Java 8 based, and the community edition is a fully functional GraalVM distribution. It can run all the programs that GraalVM will ever be able to run. Then there is an enterprise edition, which is an Oracle product, which is a proprietary thing that comes with a more powerful just-in-time compiler. So if you want additional performance, then you can opt into using the enterprise edition, right? But you can always start with the community edition, and it will be as working as the others. So currently we have the binaries for Linux and Mac OS. We are working on the Windows binary. There is an experimental version of the Windows binary available, so if you use Windows, you can try it. But luckily, most of the production systems run on Linux, and that is covered. About the product, earlier this month, I think May 9th or 10th, Oracle released GraalVM Enterprise 19.0, and it's a product, and it means that Oracle would support that until the end of times. So what it gives you the confidence that the project will not disappear and vanish, because since it's a product, it can get support. You can always figure out how to reach the team and so on. But as I said, you can start with the community edition and figure it out. Right, so with all that out of the questions, let's go and try to do the demos and see what's it all about. Right, I have downloaded my GraalVM here. And you can see that I'm sitting in the GraalVM 19 directory. If I look at what happens in my bin directory, this is what the slide that I showed you, right? Those are the commands that I can run. And if I do run my Java, which Java I have my Java from the GraalVM distribution. So on my laptop, this is the normal default Java. Always when I run some Java commands, this is this, right? If I run Java minus version, you can see that it's a JDK 8 build thing, and it's a GraalVM 19.0. So it's a normal Java coming from the GraalVM distribution, and we're gonna run it. And what it will happen, it will start the Java process, it will start the Java hotspot VM, and the just-in-time compiler, the top-tier just-in-time compiler, there is swapped for the GraalVM compiler coming from the GraalVM project. It doesn't mean that anything else is removed from there, right? It's a normal Java, so you can disable our compiler if you really want, and you will get the normal setup that you will otherwise have, where the top-tier just-in-time compiler will be C2. This will come very handy because I want to show you a benchmark, and I want you to see the difference in execution, and we're going to do exactly that. So here's the benchmark. Let me show you the code. This is a simple JMH benchmark that doesn't do much, but it exercises some methods from the Spring Reactor project. So what we do, we just have an array of integers, which is, I think, 100 elements long. And what we do, we just create a flux from that array, and then we map a couple of operations, and when we reduce that to a single number, right? What it shows you, like, this is probably not the code that you write daily, but this could be code similar to the one that you write daily if you write web applications, which is very popular in the Java ecosystem. Then you might use Spring because it's an amazing framework that many people. How many people use Spring? Nice, more than Java 8, right? What do you run your Spring with? Java 11, good answer. So, like, and if you use the reactive way of creating applications there, you will exercise the project reactor. So this is the, even if this actual code is not maybe the code that you write daily, it exercises the pass in the code that your applications also exercise, right? So, and so JMH benchmark, what I'm going to do, I can run this. And I will do this without the Graal compiler first. So I will use my Java from my GraalVM home, but I will say, but please do not use minus XX minus, like, use JVM compiler. I will disable the JVM compiler, right? And I will run it, and you will see it will take 40 seconds. And while it runs, we're going to look at the code again, right? So just let me check that it's running the correct thing. We are running the GraalVM Java thing from the GraalVM distribution. We are running without the JVM compiler, and you can see that it takes quite a bit of time to execute one loop of this operation. And you can see that the numbers go down just a little bit because it gets warmed up and the JIT kicks in and the code gets more efficient, right? So one iteration of this method, let's look at the benchmark again. We run it in the average time mode. We run 3 iterations for the measurement, 1 warm-up. This is not enough for any industrial-grade benchmark, but this is what will fit in 40 seconds. And so we measure the time that it takes to execute 1 iteration of this test method, right? So we measure time, so lower is better. It's important. With benchmarks, you never know. So 1 iteration of this method, on average, takes 2,500 nanoseconds per operation. This is like running on my MacBook, which is not the enterprise level hardware, but just like this is an approximate result. So now what I will do, I will run the same benchmark, but I will run it without disabling the GraalVM compiler, right? I will just run Java normally, and it will come from my GraalVM distribution, and I will run the same benchmark, and you can see there is no configuration saying that just please do not use the GraalVM compiler. So previously, what we saw just now, that was normal setup with C2. This is what you get when you run normal OpenJDK, right? So now this is the moment of truth. The high performance thing, I will go away from here, not to spoil the results, because I feel it's important. The element of surprise, 40 seconds is not a long time. How many of you think it would be faster than normal Java? Right. How many of you think it will be on par or like slightly faster or like slower? Right. You are kind of correct to expect that because it's really hard to be faster than the JVM. JVM is a state-of-the-art virtual machine. Many smart people put a lot of time into making its performance really, really good. But then it would be kind of very silly for me to show you benchmarks where we are slower. So taking that fact into account, we know that it will be faster. But the question is how much faster? Will it be 10% faster? 10% or more? Like, Okay, usually people go up to 50%, but like that is a ridiculous claim because being 50% faster than the JVM is ridiculous because JVM is very good performance-oriented virtual machine. But since 10% also give you some doubts, let's go straight into the data here. When we run this with the GraalVM compiler, one iteration of this method takes 80 nanoseconds per operation. 2400, 2500, 80. Lower is better. If you're not very good at math, it is 30 times faster with the GraalVM compiler here. So, which is ridiculous. It deserves an applause. Thank you. What I want you to understand that if you just swap your executable for our GraalVM bin Java, most probably you will not see the performance benefits like this. It's ridiculous to expect this. This is a synthetic benchmark running on a MacBook. Clearly, you have to be very careful trusting any benchmarks anyone shows you from Sage. This is just a reasonable life advice. But you have to understand that there is no tricks here. There is no optimizations in GraalVM compiler saying that if you see the array of 100 integers, just make map operations really, really fast. Right? There is like nonsense. There is just generic optimizations, and that means that your code could benefit from them a lot, right? Maybe not 30 times, but even 10%. 10% you said is ridiculously good. So you should be interested enough to try it on your workloads and see what it brings you, right? I can show you some data about what it can bring you. We recently published the Renaissance benchmark, which is a benchmark seed collected from other benchmarks, and we think it reflects the modern Java workloads much closer than the other industrial benchmarks. We run them anyway, right? We run Da Capo, we run spec benchmarks, we run all of them because we really want to be a good high-performance virtual machine. But we also feel like they might not represent the code that we're currently working with. So in the Renaissance benchmark, there are some reactive extensions, there are some project reactor, there are some Neo4j analytics there, like memory-heavy workloads. There are some akka stuff on top, right? We want to run code that currently you are running in production because we want to optimize for that code, for those patterns. And we get pretty good results. So here, you can see that it's normalized to the OpenJDK results. And you can see a very important part here. If you look at the community edition of GraalVM, you can see that sometimes it gives you really good performance boost, right? Sometimes it's much better. But also, sometimes it's on par with OpenJDK, or sometimes it's slightly slower. What it means, we run tons of benchmarks, we collapse that data into a single number, and we know that GraalVM Community Edition is 1% faster, or 2% faster. And we will make it even faster in the future, right? The work doesn't stop there. But what this 1% faster number tells you nothing. It's an average temperature in the hospital. You cannot derive any conclusions from that. And you also see that sometimes it's much faster. But sometimes, like if you sometimes much faster, but you come to the average 1% faster, then it means somewhere there are slowdowns. So with the community edition, what you need to understand that if you know what you're doing, if you understand performance of your application, you can try it, you can use it. Most probably for modern workloads, you will get performance boost. But you have to understand performance. If you don't want to understand performance and you just want a faster runtime, you can consider using the GraalVM Enterprise. And that will be almost universally faster, which is good. Now, if you run simple benchmarks, like maybe you run Java 8 and you are using streams and lambdas, we show good results on that highly abstract code. The GraalVM compiler has really good escape analysis, really good inlining, really good polymorphic inlining. So code using stream APIs, code using collection libraries is probably the candidate for the code that will get performance boost. If you just compute the fractal Mandelbrot something in one like double array of doubles and you never allocate any objects, maybe we will not be as excellent on those benchmarks. So you should try. We try to blog about our results so you can replicate those and try. And we try to be very open about the performance benefits. Right? You can try that. If you write Scala specifically for you, one gentleman will show really good results in Scala. So you can check it out. And also, there is a version of the GraalVM compiler in the recent releases of OpenJDK. So if you run OpenJDK 10+, what you can do, you can type up the command parameters, specific magic incantation, and you will run with the GraalVM compiler as the top JIT compiler. The exact phrase that you have to do is unlock experimental VM options, use JVM compiler, and you will run a version of the GraalVM compiler. It won't be the master, it won't have the latest and greatest, but you can enable that, and you can check, and maybe you get the performance boost just from one command line, which would be ridiculous. That is the easiest performance work you will ever do in your life. Right. How good is that version? So say you have this benchmark that people show how good the future will have when we'll have the value types, inline classes currently. And it's a benchmark that multiplies matrices of the complex numbers, and the complex numbers here are written using immutable data structures, because immutable data structures are good, right? It's how we reason about the code. We don't want to mutate global state, even though it might be faster. We want to be sure that our data stays ours, and immutable data structures are universally good. So when you run this benchmark on the GraalVM and just normal JDK 11, also the numbers from my poor laptop, you can see that just enabling the Graal compiler with the unlock experimental VM options, use JVM compiler on this benchmark gives you 2x performance boost. Mostly because here in the inner loop, this benchmark generates a lot of objects, right? So every math operation using immutable data structure will generate new objects. So the new escape analysis in our compiler, which is better, which is more practical, more pragmatic, more flexible, it can remove the allocations of those objects, reduce the GC pressure, and it will give you quite a performance boost. Again, don't expect it on your normal average applications like that, but it shows that you should evaluate that. Right, so this is the compiler from in the OpenJDK project. Twitter is one company that's using the GraalVM compiler on their, I think they run OpenJDK, and they are running their Scala microservices on that, and Chris Tallinger from the Twitter VM engineering team goes around the conferences and shares their experience with the GraalVM compiler, and they're very happy because they get a noticeable user CPU reduction time, and they get noticeable improvement to the 99th percentile latencies because they do less GC and they can serve more users with the same hardware. So if performance matters for you, for example, you run your stuff on the cloud, and there you know that for every compute power, for every CPU, you actually pay money. Performance equals money. And also, better performance, it means less electricity, and that is good for the planet. And in our days and age and the situation with the planet, everyone should be very careful about the planet. So we all should pledge to run the most efficient runtime we can find. I'm totally not trying to guilt shame you into evaluating GraalVM. No, but just better runtime is always good. The life is too short to wait for the slow software to finish. Right, so that was the bit about the high-performance virtual machine. Let's talk about, we have some time, let's talk about the polyglot abilities of GraalVM. So I told you that we can run many languages, and you would be like, oh, why would I need to run other languages? This is nonsense. I have everything in my Maven Central. And if there is also NPM, right? For everything that you don't find in the Maven Central, you can find that in the NPM, for better or worse. But the thing is, all the languages are good for their specific use cases. Java is great for writing enterprise systems. Python is great for machine learning. R is great for data science, data visualization and stuff. JavaScript is great for some things as well. No, like all language, come on, stop doing that. We're not 13. We are all mature adult people. It's a very good language as well. Ruby also has a niche, right? So being able to pick the components and libraries for those ecosystems is a good thing. So let me show you how we do this. I'm going to show you a short example. How many of you know the library called test containers? Right, excellent. Sorry, test containers. Bam, 4 people. This is the moment of truth. This will show you the goodness of the test containers library. The test containers library is the library in which you can, written in Java, so you can use that for writing integration tests and managing your integration environment for the tests, the Docker containers. So if you want to test against a database, you can spin up a Docker and have a database and run your test against that database. Or if you need a Kafka server, right, the cluster for your integration test, you can spin it up in just one command. And there is a nice API in Java because the maintainers are Java developers and they know and love Java and they're very proficient in writing Java. So what you can do, you can use that library from your Node.js application or from your Python application. So if you want to write tests for your Python application, you can use that. So how do you do that? There is a Polyglot API that allows you access to Java types, and you need to gather all the classes to the class path. And then you can use it normally. So this application, this is a Node.js, not Node.js. This is just a piece of JavaScript application. Doesn't depend on Node.js inherently. But what it does, it accesses some certain classes from the Java library, and then it uses them as if those were normal JavaScript objects, right? And then we'll show you that I actually can run this, which is quite ridiculous. So we'll start Node. We want to have access to the JVM, and then we'll have the node with the event loop and the JVM with the threads. So now you can have, using this runtime, you can have threads and null pointer exceptions in your node applications. If you ever wanted to share some information with your colleagues who write node applications, now you know what to tell them. Right? So I gather the class path, I run this thing, and it will start. I hope my Docker is running. If it doesn't run, it's not me. It ran in the morning. Right, it starts the Docker container, and it prints me the URL here. And what will happen if I access this in the browser? We see the engines, right? So now my JavaScript application accesses Java library to spin up Docker containers, to spin up engines. So I can use that for my integration tests. And you can also use the JavaScript library in your Java program. For example, if you do React, how many of you use React on the front end? How many of you know that people use React on the front end? Excellent. React is a JavaScript library for front-end things. What you can do the server-side rendering of that. If you want and you have the Java backend, you can use our technology to run your JavaScript for rendering inside your Java process. And then you don't need to do any Node.js Java integrations with additional network hop or data serialization on the backend. How wonderful, because it runs within the same process. You can also have this ridiculous, and I will try to show you just very quickly, another Polyglot application. This is just more impressive, right? It's a JavaScript application, and it uses Ruby for a thing. It uses R for visualization, and it uses Python because it can. And what it does, it binds to a URL, and it just starts, and it doesn't do much, but it takes input, the mathematical function, and then it can run it, and it can validate the function using some Ruby code here in the validator thing, and then it can plot that function using some R plotting facilities. So if I do the run thing again, right, I will run node, I will run all this thing, and I will do this magnificent thing. This demo sometimes doesn't work, so you will be in luck if it works. --inspect. This is mind-blowing, right? DevTools. So what are we starting? We're starting now an application, and we're gonna debug that using the Chrome debugger. Right? So this is our application here. It starts, and I need to open it. Localhost 8080, 8088, I think. Right? Which port is it? Come on. Port 8088, right? So we start it and we open it, and it will take a moment because it needs to initialize all those things. So when I talked about performance before, I meant peak performance, right? I meant when everything is warmed up and ready and good. So now we're listening. So now what we can do, we can run this, right? Our application is here. Now we'll go to the debugger, and we have the breakpoints here, right? What we can do, we can say, let's do a function. Sinus x divided by x. We can hit the draw function, and now we should hit this breakpoint. What? Reconnect DevTools. Reconnect DevTools. Draw function. What happened? Oh, crap. This is unfortunate. It worked just before. Let's try this again. Well, what I wanted you to show, I have a slide about that because this demo sometimes doesn't work. I'm not sure why. So there are different components. There was a different status. So Java bits and JavaScript bits are as mature and solid as possible and compatible. Ruby, R, and other things are rather in the experimental status right now. So let's quickly go through that. I'll show you the picture of what I wanted to show you. Right? So JavaScript and compatibility with ecosystem. Java bits are top-notch, right? It runs the normal JVM, so you are covered. It's just the JIT compiler which does things differently and could be more efficient. So for you, largely, the Java crowd, it can be the drop-in replacement, especially if you run Java 8. Soon we're going to have the Java 11-based bits, but currently Java 8-based builds. JavaScript, we're compatible with the languages, right? We are compatible with the language spec. More compatible than others. We are compatible also with the 2019 draft of the spec. It's not even a spec, it's a draft. And we are already compatible. So we're going to keep that. We also test the modules from NPM. We download them, we execute their tests. We run them. We understand that we provide everything they want from the platform because the tests pass, right? It's either poor tests or we are a good platform that does everything that those tests expect from. Our JavaScript is also fast. It's almost as fast as V8, and certainly is the fastest JavaScript on the JVM. It also doesn't need the GraalVM distribution to be able to run it, so it's just available as a bunch of jar files. So if you run JDK 11 and 11 plus, and you want to use JavaScript instead of Nashorn, you can just do that with a bunch of jar files. Our Ruby is fast. We run small Rails apps, but maybe not the largest Rails app ever. We're working on the compatibility, and soon it's going to be available. Our R is fast. Our Python is the youngest integration, and we are targeting the compatibility first, specifically targeting machine learning workloads. So if you are most excited about Python, just keep your eyes open when you try it. In general, the key to happiness is having low expectations, right? So if you evaluate and you're like, oh, Python, I always wanted to run Python in my JVM, and you try it and you stumble upon something, then report the issue to GitHub and we'll be happy to fix it. But just consider to trying like in a couple of months again, right? So don't just say, oh, this is very, very bad, ridiculous, and this one person on stage promised that it's going to work and then it doesn't, and I will never look at this again. No, be reasonable about that, please. So we are working on the compatibility, and we will work on performance. And if you know PyPy, this is like a fast implementation of Python. The approach we take, but we like support all languages. It's kind of similar to what PyPy does. And PyPy showed like 3x, 5x performance improvements over Python. So I would expect that we are somewhere in the ballpark there. Right. So this is the screenshot of a Chrome debugger debugging Ruby application, I think, right? So, which is very nice. Or maybe this is JavaScript, but the debugger supports all the languages. The reason for that is because for us, languages are just interpreters for the program trees. They all look the same, so the tools can integrate with the platform, not the specific languages, right? So you get for the language implementation, you get debugger, the profiler, Heap Analyzer for essentially free. I know that last year at Oracle Code 1, there was a session from Goldman Sachs. Goldman Sachs is a large bank. 25 years ago, maybe 26 now, because half a year has passed, they wanted a dynamic language for their credit and risk calculations. And 25 years ago, the ecosystem wasn't what it is now, right? Java was just starting, Python was just starting, the open source was different, the floppy disk were things, the downloads were not actually downloads, but we had the slower connections, and it was hard to download things. Perhaps, I don't know, I wasn't in the industry back then, so I cannot comment. But they felt a need to create an internal language. And now, 25 years later, they have millions of lines of code written in that language, so they cannot just throw it away. And they have to maintain it. So they looked at the GraalVM stack to maybe implement the language internally. Maybe it will run faster. They put some time into that, and they shared their lessons learned. And one thing that we're really happy about is that with very minor time investment, they got to work this mix of the language implementation where the data storage, the fields, right, reads and writes were on our side, implemented with our things, and the actual functionality was just like their old code running, right? So it was a mix. And it didn't give them any performance benefits because it's two systems going back and forth, and that's not how you get performance. But what it gave them the integration with the debugger. Because for the debugger, the fields and variables are the most important thing, right? You want to see what the data is there. And they were very happy and talked about how they are super ecstatic for not needing to maintain that integration with the debugger manually. So if you maintain a very old language that you cannot throw away, how many of you are here? Language implementers. Yeah, I knew it. Not for everyone, but this is the technology that can help you. Right, the Heap Analyzer is based on JVM, but it also understands the JavaScript objects and Python objects because to us they all look the same. Sampler. Oh, and the final bit. Yes, of course. Whew. The GraalVM native images, the technologies that allows you to compile your application to the native binary, to the platform executable for better startup. How it works? It's a full AAT compilation, and it also works with the components of the VM that you would expect it to work with. You write your Java program, and you know that it's going to run in a GC environment, right? You write it under the assumption that memory is infinite. You know that you can create objects and create more objects and create more objects, and somebody will take care of that. You don't do the memory management manually. So the compiled program will need to do that as well, because we cannot just change your code. So it will work with certain components of the virtual machine, garbage collection, the thread scheduling, right, mapping your threads to like actual operating system threads, the memory layout. So when you take unsafe and you poke into like random memory address where you expect the field of an object be, it will actually not poke into like random memory and crash everything, but it actually will do what you want. How many of you use unsafe? How many of you use something that uses unsafe? Right, it should be everyone. If you run Java, then most probably you hibernate. Spring, you use Spring, you use unsafe transitively. Not saying that it's a bad thing, but just it's an educational fact, right? So, and you can enable that, and you can compile to native executable, and you can have this binary file that you can embed in other applications, right? So if normally you have the precompiled hotspot, and then you run your Java dynamically on top of that, when you compile ahead of time, you get this just one binary blob file, right? It's just machine code that you can double click at and it will run. How does it do it? It takes all your classes, and that means your classes, your dependency classes, your JDK classes, and the VM components implementations within Java, and it analyzes everything, like what reaches what, all the bytecodes that will ever be executed, and then it just looks at that very carefully and feeds that to the compiler and gets the machine code back and writes it to disk, and it wraps into the alpha executable so your operating system knows that this is the file that you can execute. Right? Some things you need, like static analysis cannot do all the things. So sometimes you need like additional configuration to say like, oh, I'm going to load that class dynamically through reflection, and please can you make sure that that class will end up in my native image, right? So you get a file, you have to configure this, but you can configure that. Because as a developer, you have the ultimate freedom to do whatever you want with your application. You can do whatever, right? This is the ultimate power, which is very refreshing. Next time you feel like you cannot do something with your software, reconsider. You can do whatever you want, which is excellent. Right, so what it gives you the startup time in milliseconds. We tried on the sample native server. On the back end, you probably have applications running Netty. It's a very popular project. So normally it starts in a number of milliseconds, and compiled as a native executable, it starts in a very few milliseconds. Right, literally less than 100 milliseconds. And it also, because at runtime there is no technology, no machinery to deal with additional compilation, or it doesn't need all the classes in the JDK standard library, because it analyzes what you actually use and only uses that. So it has a much lower memory footprint. And there are a number of frameworks currently in the ecosystem who said that, oh yeah, we want that. This sounds like a cool deployment strategy. So, and they say that they support GraalVM native images as the artifact for their applications. So currently, you can build that with Halidon or Micronaut or Quarkus. And I think the next session, the closing keynote today, will be about Quarkus. So they're going to hopefully show the GraalVM native images capabilities as well and talk maybe more in detail about that. But the thing is, normally, you would take this much time. And when compiled as a native image, you will take just a tiny bit of time to start the things to be ready to render the first requests. What it gives you the ability to deploy into serverless platforms without actually paying the startup costs of the virtual machine. And also it uses less memory. And you can see that there are differences between frameworks, but, well, compared to the actual benefit, it's maybe negligible, or at least seriously considering the configuration. So the Spring applications. Spring framework pivotal people said that they will look into this very closely, and they announced at the Spring I/O Barcelona recently that they will get the support, and we're working with them, and they're working with us, and we both the teams want to make it happen, right? So in the future, Spring applications will be capable of doing native images as well, right? Windows builds native images specifically are in the works. Java 11 native images are in the works. We can do other cool things, like run your native code in a virtualized, sandboxed, managed environment, and where your random memory access will become exceptions, and so on. So it's a very cool project, can do many things, but you want to remember out of this session that it's a high-performance polyglot virtual machine for many languages, embeddable in native and JVM applications, and that those are the main values that you can have in mind when you consider GraalVM. Thank you very much. I don't know how much time it is. I think it gets to 0, so I don't think we have time for questions. But I will start gathering my things very slowly. So you can ask some. Do we have time for questions? Oh, we have time for questions. Really? Wait, sorry, 10 minutes. Why didn't you tell me? Stop going. Come on, come back. No worries. Yeah, questions. I don't see you. Like, there is a hand, sir.
The difference between Oracle JDK and OpenJDK performance-wise, because you didn't show it in the comparison. And the second question is, if I seriously want to do it for a bigger application, just replace Grail, it will work out of the box? Or, like, for example, Java 8, if I would use OpenJDK, some stuff is not in there in compared to Oracle JDK. So this 2 questions.
Yeah, good question. Comparison to Oracle JDK. I don't know performance differences between OpenJDK and Oracle JDK, especially on the level of Java 8. I know our community edition builds are based on OpenJDK. I know that our enterprise, GraalVM enterprise bits are based on the Oracle JDK, I think. So, but that is the proprietary product, right? So essentially, I don't think there are very many performance differences between OpenJDK and Oracle JDK. What I know that starting from 11, they're essentially equivalent, right? So I'm sure that could be some difference in the components, but that is has very little to do with the just-in-time compilation, right? In that regards, I think they're similar on that level as well. So, and the general question when you say, like, if I swap the things and will it work on the GraalVM? If it worked before on OpenJDK, then it will work with the GraalVM Community Edition, right? Because it's the OpenJDK with the JIT compiler swapped, and like everything will work. And if it worked on Oracle JDK, because you see there were differences at the time when 8 were released, then it will work with the GraalVM Enterprise Edition, which is based on the Oracle JDK. Right. Any more questions? Here was some question in the first row. No worries. Careful. We have 10 minutes, actually, like, so we can go slowly.
I'm actually curious why Enterprise Edition is that much better. You're selling additional optimizations under Enterprise Edition.
That's a very good question. Why is Enterprise Edition so much better? And it's somewhat a philosophical question. Why different JIT compilers have different performance characteristics, right? They have different optimizations, and they produce different machine code for different workloads. So the compiler, the JIT compiler in the Enterprise Edition, received much more work. It's more sophisticated. It has additional phases. It has additional optimizations. So it is much more sophisticated compiler. And it was intended to be a better compiler. So that's why it shows better results. Because more work went into creating that. Specifically, one thing that I think is different optimizations-wise is the auto-vectorization of things. When the compiler like parallelize your execution, kind of vectorizes your operations. That is largely in the Enterprise Edition of the GraalVM compiler. Right? But then again, it's kind of... What I want you to take away from this is that, as I showed you, and as you can see in the benchmarks and the results that we publish, the GraalVM Community Edition can be faster than other runtimes, and it can bring you the performance benefits, but you just need to realize that, yeah, this is the performance benefit that I get, right? And you don't get the support where you take the phone and yell at someone for things not working or being slow. And there is a commercial offering that you can opt into, which I think is very relevant because it's a large open source project. It requires a lot of very intelligent engineers working on that. So having a monetization strategy that is based on the opt-in features is essential for the liveliness of the project. So it's a good question, but...
Do I understand correctly that these additional optimizations, they are open source?
Yes, the additional optimizations in the GraalVM Enterprise compiler are proprietary code written by Oracle engineers put into the proprietary Oracle product, not open source. And the other optimizations that are in the Community Edition are written by Oracle engineers, the same brilliant people, put into the open source. And that one is open source. Right. Any more questions?
So 2 questions. Is the fast startup only for native? And are there other languages supported in native mode?
Right. So the fast startup, this ridiculously fast startup, millisecond startup, is the feature of the GraalVM native images. So it's specifically when you compile your things ahead of time to the executable. So normally if you run graalvm/bin/java, it will run the normal JVM. It will have all the characteristics of the normal JVM because it is a normal JVM. So yes, the fast startup is the GraalVM native images feature. And currently you can compile bytecode, right? So if you can embed into that like final image, final executable, you can embed the infrastructure for running JavaScript or Ruby. So you can still run those, but they will not be, like JavaScript or Ruby code will not be compiled ahead of time to machine code as of right now. Our way, so it will start up, it will start interpreting things, it will start working with the trees, and then it will compile that ahead of just in time, sorry. It will compile it just in time into the same efficient code. But it will not compile that ahead of time, right? And we can increase this startup, decrease the startup, make startup better. Sorry, for those languages as well. For example, by pre-compiling certain parts of the standard library into the GraalVM compiler graphs, rather than starting from the source and the trees always, right? But still, it will probably in the near future, it will still be the JIT compilation that works there. But still, you can compile your bytecode parts into the executable and then still have the runtime bits for other languages. Sorry, did you ask something else? Oh, yeah, excellent. Any more questions? Yeah, okay, we don't have any time. If you figure out a question, find me online. I'll be happy to answer to the best of my ability or point you towards the people who know much better. Thank you.